Hey guys, and welcome back. So now we have the fracture done. I think it took about 8 minutes for it to finish, and we have went from how much? From 500 points to 3.6 million. So that's a huge increase, and we went from the number of pieces 100,000 basically, and the starting point was 1800. So that's a huge increase in terms of resolution, and this is how the fracture looks like. And even though it's a bit uniform at the moment, we can always use the RBD cluster to group things. We can even do a glue constraint on top, but it's not gonna matter. We're gonna have so much details that it's gonna look interesting with motion blur and everything. So the next part is we want to transform this guy. So if you guys remember, we left off a copy of the name attribute, and we also have, what do we have? We have our geometry, our transform pieces. So let's see if this works. Okay, so we have this, and it's V12. So let's use this, and let's copy this as well. And we want to, yeah, it's fine, let's use this guy. And obviously it's not going to work, so we need that main name again. So s at main name underscore name is equal s at name to make a copy. And we want the transform piece node to respect that. And we should have our geometry transforming. Now we don't have the bricks because we removed those guys, and they're not going to be part of the RBD system. So this is our high-res geo transforming. So the trick now is to generate the activation, and the activation is going to be generated based on the distance that separate the pieces. And the idea is we want to create a link that stores the connection between these guys. Okay, at the first frame it's going to be 0. All the pieces are tucked in nicely, there is no separation, and then as they start to separate, this piece here is getting further from this guy. We're gonna flag those as to become active. Okay, we're gonna say, okay, you've separated enough, I want you to become active. And this is what's gonna give us that erosion effect. Now we don't want this to only activate the outer edges, because this core here is never going to separate. Okay, this is the block. We're only going to be able to activate the outer layer. We don't want that. We want to create a transfer effect or some kind of growing effect, where if the edge starts activating, we want it to start eroding. And so we're going to use a SOP solver to grow that data in, but we don't want to eat out all the pieces. We don't want to kill the entire geometry. And so we're going to create a mask that says, okay, this is your limit, do not go beyond this point. And this way we can, for example, with these guys, we will be able to activate certain region, and then once that happens, it will start growing in, and we'll see pieces falling down basically as we progress. And so that's the main idea. And let's see. So what we need for this is I'm going to separate a couple of pieces because this process is going to be slow, and I'm going to do that using. I'm gonna first assemble this. Yeah, let's assemble it. And I'm going to select a few pieces from this region. Let's make sure. Yep, that's how much pieces we have. So I'm gonna blast this and delete non-selected. We have to make sure that we transfer that name attribute so that we can transfer them here. Okay, so we have these guys, and let's unpack it. We need the unpack geo. Okay. And I'm not gonna care about the outer edges. I just need the inside faces. We need the inverse. So this is what we're going to use to generate the connection between the geometry. And we're gonna build a link between all the neighboring points. If we preview all the points, you can see there's a lot of points that are overlapping. We're gonna build the connection between them, and then we're going to update that connection with the transform pieces. And if at frame 0 we're going to compute the length of that primitive, we're going to create a connectivity, we're going to compute the length, and then as it transforms we're going to continue to recompute the length of the connectivity. If the length gets higher, it gets longer than a certain point, we want to flag the pieces that originated from. We want to say, okay, you guys have separated enough, go become active. And then if those becomes active, we want them to activate the neighboring pieces around them. So that's basically the method. But before I start building the connection, I want to briefly show an example of the growing effect using a SOP solver. So here I have a very simple scene, and I have a sphere, and I have a point cloud, a grid with points on it. These points are black and these guys are red. So first frame, I want to transfer that by hand. So I'm going to transfer this, and I'm going to use a small region, and I want to grow this effect over time using just a SOP solver, nothing else. I'm not going to use a second import or a second sphere. I have an attribute, I want it to grow independently from what it originated from, or if I need a second input or anything like that. So I'm going to use a SOP solver, and I'm going to use an attribute transfer again. So I'm going to transfer between the previous frame. Sorry, I'm going to transfer to the current frame from the previous frame. I'm going to transfer the CD attribute again. I'm going to use a smaller radius, and I want to keep doing this over time, over and over and over. But if we do it this way, you can see it's not changing here. It's not changing in the graph. And the reason for that is because we're doing the transfer from this point cloud, from everything where we have black is gonna still transfer black, and red is still gonna transfer red. So we want to separate that. I'm gonna use a blast node. Say if the red is less than 0.2, I want to isolate those points at CD, and I want to separate them. And then I don't want to transfer from this anymore. I want to transfer only from here. So this is what I'm going to connect. You can see it really grew in one frame. Let's reset this, and let's hit play, and now it's growing. Let's reduce this by 0.1. Let's hit play. You can see now it's growing. And if we animate the sphere from here to here and hit play, you can see it's gonna travel, and every time it's gonna keep growing and transferring the attribute to the geometry. And the trick is we're gonna transfer the attribute after isolating the active ones. Now obviously we can introduce some blend, we can lower the radius, and this is gonna define it's gonna define how fast it grows. Actually, we don't need the blend. It's gonna define how fast it grows. Okay, and another thing we could do, this is just a bonus thing, we're not gonna use it here, but we can add a noise to the geometry. And let's first store the rest. and we can add a noise to the position using this attribute noise node. And I'm going to lower this to 0.1, 0.1, 0.1, maybe 0.2. Okay, and let's scale this. Now the transfer is going to respect that noise pattern, and then I want to restore the point position. I don't want to change them. Okay, I want to do the transfer using a deformed point cloud and then restore that. So v is equal at rest to restore the original state. And let's go back up and let's hit play, and you can see now it's respecting that pattern, and it's growing following the noise pattern. This is a very simple trick, and we can animate the noise as well. Let's try $F multiplied by 20. Let's hit play, and it's the noise is moving along this path. But we're not going to do that. So the idea is we want to let me turn this off. We want to grow. Let's remove this guy. We want to grow the mask or the activation over time, and this speed controls how fast they start eroding the debris. If the edge activates, we can control how fast it propagates through the entire geometry. And then the last thing is, I'm gonna do it here. We want to say, I'm gonna use this guy. Okay, and I'm gonna call this f equal limit v at cd.x. So I made an attribute where it's equal to 1 here and 0 here. So that's my limit. And let's connect that. So now I have a limit attribute, and I'm going to dive inside this guy. I'm going to say v at cd multiply by limit. So this way it's going to always be 0 outside this. And let me delete the color from here so we don't override it. Okay, so we have no color at this point, or actually we can reset the black color. Okay, so we did the transfer to create this mask, this region, and then we restored that. So we have our attribute, and if we hit play, it's gonna grow, and then it's gonna stop. So that's these guys are basically our no touch zone. So that's what we're going to do. We're going to create the wires between the pieces and then transfer that information if the length is higher than X. And then from there we want to start activating the geometry. So we'll start implementing the connection between the pieces in the next video. Thank you guys for watching, and see you in a bit.